Hey guys, it's Jake Smith. Today we're going to be looking at using buttons with Arduino. Specifically, we're going to write some code to debounce a button without having to use any extra libraries. Buttons are very common components in electronics projects, and often you can use them without having to add too many lines of code. As things get more complicated though, an issue can arise due to a phenomenon known as bouncing. If you've tried toggling an LED on and off with a button, you may have come across this issue. Bouncing occurs when the plates within the button vibrate against each other a very small amount, leading your Arduino to think you've pressed it multiple times, when you've only actually pressed it once. In this video, we're going to look at how to write some code from scratch to eliminate this issue and make your buttons work accurately every single time. Okay, we're going to start by setting up our breadboard. Now we're using an Arduino Nano for this circuit. This would work with any Arduino. We'll use this because it's nice and small and they're nice and easy to get hold of. So we're going to put it towards the top of the board so that we have enough space to fit in our button here, in between ground and digital in pin 3. So going to the sketch, we'll start by creating a new integer, call that pin 1, and that is equal to digital pin 3. That's the pin that we're using now. Next, we need to start the serial monitor up so that we can read some outputs. We'll use serial begin and we'll set the baud rate to 9600. Now we need to set the input mode. So we're using pin mode and we're doing this for pin 1 and we're going to use input pull-up. Cool, now we can go to the loop, and within the loop, the first thing we want to do is read the input. The way that we do that is by creating another integer, call that button val, you can call this whatever you want, and we're going to make that equal to the digital read of pin 1. We're using digital read because buttons only output two different values, 0 or 1, or on and off, and digital read works with zeros and ones. So now we're going to create an if statement to see if the button has been pressed. So if button val is equal to low, now we're using low because the input pull-up resistor that we're using actually flips the value. So when the button is pressed, it will read low instead of high. And low and high are interchangeable for 0 and 1. So we're just using low because that's nice and visual. If button val equals low, then we want to serial print a message. We use serial print line so we can create a new line after each message we send. And we're going to say button pressed. Okay, great. Now verify our sketch. While that's doing this, plug in the Arduino Nano. And make sure we've got the correct port and board selected, and then we can upload. Great, so that is done uploading. We can open the serial monitor, this top right hand corner button there, and let's press the button and see what happens. Now immediately we've got a problem. We're getting this same message printed many times, and that's because this sketch is basically saying, is the button pressed? If so, print, but then it's looping. So because the loop happens incredibly quickly, it's going to be outputting button messages very, very quickly every single time it reads the button as being pressed. So even if we go really fast, you can see it still is outputting lots and lots of messages, which is not very good. So what we want to do is we want it to only output a message if the button state changes. And only do that once. So the way that we can do that is, first of all, create a new integer, and we're going to call it old button, and we'll make that equal to -1 so that it avoids confusion to start off with. And then we're going to change our if statement to say if button value is equal to low, and we're going to check that the value has changed. Now the way that we do that is we say button val is not equal to old button, and we'll verify that and upload it. Great, and check the serial monitor. and oops, it's still doing the same thing. Now, the reason that this is happening is because we haven't actually changed the old button value. So every single time the loop is doing this check, it still thinks that the old button value is -1. So it still thinks that the button value is different. So the way that we fix this is we say old button is now equal to button value, and that should fix our problem with it repeating. So let's verify that and upload. Great, check the serial monitor and press it, and cool, it works. Or does it? Press it again and we're not getting a value again. If I reset this, then I can press it once, but it only works once. And the reason that that's happening is because we're not resetting the old button value to high or off, basically, after it does this sketch. So the way that we're going to deal with this is we're actually going to get rid of this if statement and write a new one. So we'll go if, and this time we're going to just check if the button value has changed first. If button value is not equal to old button, then first of all, we're going to make old button equal to button value so that it knows that it's changed. And then we need a second if statement. This time we're going to check now for if the button has been pressed or not. So if button val is equal to low, then we can serial print our output, which is button pressed. Let's add a space there, make it all nice. Cool. And now if we verify this and upload it, then this should be working a lot better. See how it works. Done uploading. Let's check the serial monitor, clear it, and let's press the button. Now that looks like it's working. Press it again, that's fine. And actually this is working remarkably well, but you might have noticed there that I pressed it once and it read the output twice. Oh, there you go. I only pressed it twice and it read it 3 times. Now the reason that this is happening is because the button is bouncing. So when you press the button down, the plates connect, but they actually sort of vibrate very minutely and very quickly immediately after you first press it. And because the Arduino is so fast, it reads these vibrations as individual button presses. Now the way that we get around that is we tell the Arduino to only listen to the first one and then wait for a period of time to wait until after the bouncing is finished, and then it can check again. So we need to actually have a way of checking time. So the way that we can do that is by creating a long, and we're using a long because we're counting milliseconds now. And there's 1,000 milliseconds in a second, so that value can become very big, very fast. I'm going to call it delay val and make it equal to millis. Now the millis function is basically just reading the number of milliseconds that have passed since the sketch started. And because we want to check a time interval, we're going to create a second long within the setup before the setup function, call it old delay, and we're going to start that off at 0. So if we go back to our if statement here, we can add a secondary check, and this time it's going to check that the delay has passed, so it's bypassed the bouncing, and we're going to write if delay val, so that's the overall time, minus the old delay is greater than, and this is where we input the period in milliseconds that we want it to wait for. We use 50 milliseconds because that is usually more than enough to allow debouncing. And then again, we need to update the old delay. So we'll say old delay is now equal to delay val. And if we verify this and upload it and then open up our serial monitor and let's try. And there you go, it's working perfectly every time. So let's press the button 6 times. 1, 2, 3, 4, 5, 6, and we've got 6 values outputted. So that's a much more accurate way to read button inputs. If you want to, for example, sorry, my cat is trying to get in the video. If you want to, for example, create a counter, this way you're not going to accidentally count more numbers than actually being pressed. Thanks for watching. If you found this video helpful, please give it a like and make sure to subscribe to stay up to date with any future Arduino tutorials. If you have any questions or perhaps an idea for a topic you'd like me to cover in a future video, please leave a comment below and I'll get back to you as soon as possible. If you'd like to learn more about writing your own Arduino sketches or designing and developing your own electronics projects, why not shoot me an email to the address linked below. I offer one-to-one teaching and support for beginners to intermediates at a competitive rate. Alternatively, why not check out my Fiverr page to see if any of my gigs fit your requirements. Well, that's all for today. All the best for now and see you next time.